All right. So, what my focus is for today is to start you on that vocab. Surely I wrote down which two I wanted to show you guys. Nope. Let me get that worksheet. Not here. Because I need to know what chemical reactions I gave you guys. Did I type it on my computer? Maybe that's what I did. Yes, I did. Okay. Cool. So you guys did 4 redox experiments, but I only want to talk about 2 of them to start off with, the simple ones, because I don't want to touch on oxidation number just yet. If I said the word oxidation number, hopefully that sounds kind of familiar to last year. Like I said, I'm going to hold off on it because we don't need it quite yet. So the first reaction that we looked at, or that I want us to look at, is iron, which was Fe, and it was in a solid state. And you took that nail and you put it into a test tube, and you put it into a solution of copper sulfate. SO4, and that was aqueous. Are we good so far? All right. Cool. I don't have my resource sheet. Neil, can you grab me your resource sheet when you come back, please? The pink one. Yeah, the hard one. Yeah, that one. Because I realized I probably would want to write on that. No more of the white ones? All right, I'll come over and have a look. All right. Cool. So with iron sulfate, we mix those 2 things together. We are stating our observations. So with iron, you should have written down that it was like a gray metal, solid. And with copper sulfate, you should have written down that it was, wrote down, that it was a blue solution. We good so far? We mixed the 2 together, and what did you notice happening? It started turning like rusty. So like you notice the nail started having this brown metal on the outside. When we look at that resource sheet, if we're trying to figure out what that brown metal is and thinking about what we started with copper, we started with sulfate, we have iron. So we're looking at like those kind of 3 things and getting an idea if anything says brown, and this one says brown. So what we could figure out from there was that brown metal forming on the nail was copper. We good so far? All right. So if I was to start writing my equation, I had copper, Cu2+, which is aqueous. That was blue. We had iron, Fe, which was solid, and that was a kind of gray. And then with that reaction, we saw Cu, and then we're going to figure out what the rest of that is. So that was solid now, and that was brown. I'll have a look around for it, Neil. All right, so that was the first thing we observed. What did we observe with the solution? Did it stay blue? No, it got paler, didn't it? Which makes sense because we're losing the copper ion. Now, the other one you probably wouldn't have seen as easily, and that was the iron 2 that was forming. The iron 2 is that orangey color. We good so far? All right. How did I know it was the iron reacting and not the sulfate? If it was the copper sulfate, then it would have reacted by itself. It didn't react until something was mixed in with it. So I know the sulfate there is not involved in the reaction. It's a spectator. Yeah? So that's what we need to decode when we're looking at information like this. Alrighty. So the reason why I wanted to set this up as an equation was just to review some of our vocabulary. And what I'm going to do is I'm actually going to pull this equation into its half equations. So this is the full equation. But if I was to pull into its half equation, I would have copper, Cu2+, forming copper the metal, aqueous, and solid. Now, in this case, we can look simply at the charge of the ions to figure out what's the oxidation and what's the reduction. So I see that I have a +2, and now I don't have that charge anymore. So this guy here must have gained electrons in order to reduce that charge. So we're doing 2 electrons there. So if I think about my mnemonic, Leo the lion says grr, or if you want oil rig, I don't like oil rig as much because of climate change. This one has gained electrons because we see it's on the product side. So if I think Leo the lion says grr, it's on the product side, it's gained it. This is my reduction reaction. I probably should have done these in different colors. Sorry about that. Now I'm just gonna stick with the blue. We good so far? All right. Lining it up again. Here's my iron. That's a solid going to iron 2. That is now aqueous. All right. Electrons. I see that this doesn't have any charge, and now it has a +2 charge. So it has what happened? It's been oxidized. It is lost electrons. So if I want to show lost electrons, product side. Oops, sorry, that should say reactant side. No one caught that. You guys got to catch my mistakes. All right, so that one's on the product side. So that means my electrons have been lost. Gained electron. Lost electrons. So we see that the electrons that were with the iron have now been lost, and now I'm left over with the iron 2, and that is my oxidation reaction. When we're talking redox, you should always have one of each. If you have 2 reduction reactions or 2 oxidation reactions, you have 100% done something wrong. We cannot create or destroy matter. So you should always have, like, these are ways to just dummy check yourself. You should always have electrons on each side of the arrow. So here's my arrow. Make sure there's electrons on that side. Make sure there's electrons on that side. Okay? I've done that. That's fine. I have a reduction. I have an oxidation. Are we good so far? This hopefully rings a bell. All right. Now the words that you probably don't like as much. Do you remember oxidant and reductant and how confusing it was? Yes. Yeah, you got to use those again. All right. So copper 2, this is the reduction reaction, but we don't call it the reductant. We call it the oxidant because we're talking about what it's doing to the other thing. So copper 2 is oxidizing iron. So we call this the oxidant. You might also hear it being referred to as oxidizing agent or oxidizing reagent. I know it's stupid, but somebody decided that, and that's what we're stuck with. Right. Iron then, you're talking about what is it doing to the copper. So this one is reducing the copper, so that becomes the reductant. Don't you love it? Terrible vocabulary. Yeah. Oxidant, reductant. This hopefully ringing a bell? All right. Cool. I'll give you guys the second reaction that you guys did that you can do at this point was magnesium and hydrogen. So you had that gray metal. And you placed it in hydrochloric acid, HCl. Got it the wrong way around. Aqueous. All right. So if I was thinking about the observations, we saw gray metal, that gray metal disappeared. So that suggests to me that the magnesium is becoming what? The magnesium ion. It's on my list. I look for it. There it is. Colorless, in solution, makes sense. I didn't see any color change. All right, the hydrochloric acid. Now there's, again, that same problem. We have the hydrogen ion and we have the chloride ion. We have to figure out which one is involved in that reaction. So when we put the two things together, we saw bubbles. Were those bubbles colored? No. So when we're looking at our two bubbles, we see chlorine, which is a pale green, and we see hydrogen, which is colorless. So which one is it? The hydrogen. Also, hydrogen's flammable. That's why I had you guys do the pop test. Chlorine is not. So I'm going to write that half equation down. And I'm going to be nice. I'm going to balance it. Solid, aqueous, aqueous, gas. All right. Looking at that equation, I want you guys to identify the oxidant and reductant and write the two half equations so you can show the oxidation and the reduction. Give it a go. We got other things to cover. Okay. Cool. Let us move on. I will write down the answers. So, and I'm running out of paper, but I want to put it all on one page. Okay. Mg becomes Mg2+, and you should have 2 electrons on that side. It has lost electrons, so this is your oxidation reaction. And that's your reductant. All right, hydrogen. 2H+, becoming H2. It has gained 2 electrons, so that way it doesn't have that charge anymore. This is the reduction reaction. And makes the hydrogen ion the oxidant. Cool? All right. What time does this period end? 25? No. Just watching our time so we don't make decisions. 25. All right. Cool. I'm just trying to think with our time what else I have to do. I think we should. What else is on my agenda? Electrolytic cells. No, we have time for GimKit. Let's play GimKit. All right, can I move it? I'll freeze it and I'll get GimKit set up. You guys remember GimKit?